Okay, so in this video, I'm going to take a look at, again, big data, new tricks for econometrics. This is in the Journal of Economic Perspectives. The Journal of Economic Perspectives generally tries to provide a little bit more transparency in understanding different economic phenomena. Obviously, since the early 2000s, data, big data, the Facebooks, the Amazons, Apple, so on, have become hugely important and people are taking note. And interestingly also, Halvarian is either is currently or formerly was the chief economist at Google. And prior to that, then he was quite a significant micro economist with a well-known textbook and numerous papers. So a very serious researcher who kind of spans both the world of economics and big data. And he points out that econometricians could actually learn quite a bit from the computer science people, the data science people. And interestingly here in this, if you follow the portal address here, you can download the paper, the PDF. We'll have a look at that at the moment. But all the estimations that are performed are made available here in the dataset, so you can actually download a zip file with all the R files, and that actually could be useful then for somebody trying to. So you can download that ML data. It comes up as a zip file. Okay, and there is R and some data and so on. Okay, so for our purposes, for the moment, I'm just going to take a look at the actual paper. So I'm going to download the PDF. It's already actually open here in the browser. And I've already addressed in a previous video the techniques here developed for the Titanic dataset, which were posted on Kaggle. Another interesting development for academics and computer scientists who compete to explain with varying different statistical models a particular phenomenon. One in particular was the survivorship on the Titanic, which sunk in 1912 on its maiden voyage. And already I've dealt with that, so I won't labor too much. But interestingly, Halvarian outlines a classification tree, and then subsequently runs a logit estimation, logistic regression for survivorship, and then turns his interest to a dataset for HDMA, for Home Mortgage Disclosure Act. So there is actually a group of, we'll just take a look here in R. Now there was 2,380 observations in the dataset. This is all available in the download available with the paper. And then we have a number of columns here. We have 13 columns. We have DIR, so we can check here in the Rstudio viewer what the different headings are. Turns out I went back to the original Stock and Watson textbook, and they have this, they cover this area, HDMA, in one of their chapters related to logit and probit estimation, and provide definitions for each of the variables. Also, there are definitions in the R code, but just for illustration here, the DIR variable relates to ratio of total monthly debt payments to total monthly income. So the higher the amount of indebtedness relative to your monthly income, the more difficult, obviously, it is to make that repayment, and the higher the risk of probably default, and then correspondingly, the less likely we would imagine banks would be in terms of accepting people for mortgages. So the economic phenomenon that's been addressed here is to what extent are individuals, we have a number with 2,380 applicants for mortgages, those who find themselves in buckets here where it's predominantly black, now black in colour, you will note that they were rejected. And then where we have grey, predominantly individuals were accepted for those mortgages, and we have here N equal to 1,272. So if you fulfilled, if you obtained, if you were accepted for mortgage insurance, yes, or if you were denied mortgage insurance, yes, quite likely, now it's only a small group, but most of those weren't accepted then subsequently for mortgages. If you weren't denied mortgage insurance and your credit score was quite low, that means good, and the extent to which your monthly payment was relatively low relative to your overall income, less than 40%, and if your credit score was even better than less than 3, was actually less than 1, then overwhelmingly in that category of 1,272 applicants, we would find with the ctree type construction that people were not rejected for their mortgage. So yes, you're rejected, no, not rejected from mortgage. Those people who were rejected for deposit, for mortgage insurance, that highly correlated with being not accepted for the mortgage application not being accepted also. But that is a relatively small group here when we look at that. Figure 5 shows a conditional tree estimated using the R package party. That package quite recently, again this paper is 2014, I think in 2019 that now is Party Kit. A more updated version of this package is available called Party Kit. The black bars indicate the fraction of each group who were denied mortgages. The most important determinant of this is the variable DMI, denied mortgage insurance. Other variables are DIR, debt payment to total income. So we saw that here. So the bigger proportion that the monthly mortgage payment consumes in terms of your overall monthly income, then we find that you have less chance or greater chance of being rejected. If it's lower, if the DIR is lower than 0.43 and the credit quality is even better, less than or equal to 1, then very few rejected. If it's higher than 1 and there's some history of non-payment of debts, if there's a public record of non-payment, then things are not as good, but not such a big category, only 37 individuals. If there's no public indebtedness higher than 1, that means that would imply 2 or 3, so less than 3, greater than 1, less than equal than 3, greater than 1, no public record of that. Again, quite a big group here, for 479 individuals who would have been accepted predominantly for their mortgage application. Other variables are DIR, debt payments to total income, HIR, housing expense to income, LVR ratio, the size of the loan to assessed value of the property, CCS, consumer credit score. Okay, so we'll take note of these variables as we go through, and their magnitudes and their ranges. If the CSS is high, so higher than 3, and there is outstanding debt, there's a public record of indebtedness that wasn't paid, then again a high chance of being rejected for the mortgage. So that's equal to, although a small group. And again, if not, but the loan to value ratio is in excess of 0.95, also high probability of rejection. So these things tend to correspond with our view of perhaps the underwriting process and how banks might assess the credit wordiness or the default risk of individual mortgagors or prospective mortgagors. And we can see, we can trace out in a very interesting way, a very visually effective way, using the ctree, what the likely values are, what the likely indicators are of, yes, being accepted for the mortgage or not being accepted for the mortgage, or then nuances. So again, if the loan to value ratio is quite high, the more indebted you are relative to the value of the property, the higher the risk of being rejected for your mortgage. But if it was lower, and let's say the level of monthly expenditure, the DIR, the level of debt with respect to the monthly income, if that was quite low, and if the individual wasn't African American, then yes, strong chances here, strong probability of being accepted. This is not a terribly small group, n equal 246. We do see if you observe all these and you are not black, that means white or other ethnic group, you seem to have a higher chance of being accepted. If you are black, then a slightly reduced probability of being accepted. The difference between the two here is hard to tell. In the paper, Halvarian would say, according purely to this metric, if we just purely look at this doesn't look that statistically significant or important in conventional terms. We just read through the consumer credit score, MCS, mortgage credit score, PBCR, public bad credit record. DMI is denied mortgage insurance, self-employed, single applicant. So there's some variables that we included in the analysis but didn't output on the C tree or the conditional inference tree. Condominium, if the building is a condominium, that doesn't appear here, and so on. Race wasn't, let's just have a look at that, what he says here. Monell, Tootle, Brown, McInerney, 1996, examined mortgage lending in Boston to see if race played a significant role in determining who was approved for a mortgage. The primary econometric technique was a logistic regression where race was included as one of the predictors. The coefficient on race showed a statistically significant negative impact on probability of getting a mortgage for black applicants. This finding prompted considerable subsequent debate and discussion. See LAD 1998 for an overview. Here I examined this question using tree-based estimator described in the previous section. The data consists of 2,380 observations of 12 predictors, one of which was race. Figure 5, that's what we were just looking at. Figure 5 shows a conditional tree estimated using the R package party. Okay, so okay, let's go back into R for a moment and just run some quick analysis. So we load up into the library, you see that, so economic data, and that's a package that has, and we also load up party. I've installed party as well, so that's a package that produces the C tree, and then the data is available inside this package. So I call up the data. Let's just clear this for a moment and clear here, just clean it out, and I'll clear the console, edit clear console, and I'll run. Okay, and then call up the data, and the data's there, 2,381 observations, again with those headings. And we can change the name of the condominium. So for instance, not that important, but we can change this to condo. Right, so let's run that for a moment and go back in, and you can see now it's condo, right? Slightly abbreviated. Again, the headings are there and explanation, and then we can do summary. So okay, in the next video I will take a look at some of the descriptive statistics and we'll have a look at that ctree, set it up in R.